One particularly important application of Bayes' theorem, of using tree diagrams in reverse, is in medical testing. Suppose we have this scenario. A certain percentage of people in the population have a disease. Let's say it's very low, like most diseases are, say 2%. And then the rest of the population do not have the disease. So that will be 98%. This could be a particular medical condition. It could be pregnancy, HIV, or any particular test that you want to do for a medical condition. So we then do the test, and the test either registers you positive or negative. If you have the disease, the test will normally pick it up. Let's say the chance that the test detects the disease is 95%. That means on 5% of the occasions, the test will register you negative, even though you have the disease. And that's reasonable. The problem is that even if you don't have the disease, no test is perfect, and you will still get some positives from the test. Also, of course, negatives. Let's say we're going to get a 4% rate of the test saying you're positive when you don't actually have the disease. These are called false positives for obvious reasons. And so there's 96% chance that if you don't have the disease, the test comes out negative, as it should. As before, we can now multiply along the branches, and we're going to be mainly interested in people who have a positive result from the test. So that's the top branch. If we multiply along there, 0.02 times 0.95 comes to 0.019, and along this branch, which produces positive results for the test, multiplying together 0.98 times 0.04 gives us 0.0392. And again, it's convenient to make the two numbers into the same number of decimal places. So that's 4 decimal places. We'll make this into 4 decimal places. So what does this tell us? Well, again, a good way of looking at this is to make these into whole numbers. Suppose 10,000 people had been analysed from the population. So out of 10,000 people, the number with positive test results, well here, if we multiply by 10,000, we get 190. And here, the other group who come out with positive test results, we get 392. And so the total number with positive test results is 582. So if you've gone to the doctor, you've had your test, you've got a positive result, do you worry? What's the probability that you've actually got the disease? Out of those 582, the number who actually have the disease is in fact just 190. So the probability that you have the disease given a positive test is actually 190 out of 582, which is roughly equal to a third. And so we need to be very, very careful and thoughtful whenever we have any sort of test like this. Just because you're positive doesn't mean you've got the disease. And the reason we can see from the tree diagram, it's just the numbers. So many people in the population don't have the disease, 0.98 compared to 0.02, that when you multiply this, even by the very low probability of the test being wrong, we still get a number which is much bigger than the true number of positives with the disease. And so this swamps that one. It gives a total number of positives which actually is much bigger than the number who actually have the disease. And so the retrospective probability of having the disease from a positive result is actually quite low.